Alright, here we go. We're talking about hyperbolas today, which is like a graph. Just this black part is the actual hyperbola. All this dotted line nonsense is just some asymptotes and such, but it sort of looks like a set of two parabolas, doesn't it? But, you know, they're not really parabolas. They don't follow the same rules that parabolas do, and they have asymptotes, and parabolas don't have asymptotes. So anyway, this is what a hyperbola looks like. It's a two-branched thing that has some asymptotes, and it has a lot of similarities to the ellipses because we have vertices, and in this case, these guys right here are the vertices. Vertex number 1 and vertex number 2 over here. Those are the vertices. Now, this is one difference, though, is that the co-vertices could actually be the bigger number. Don't let that freak you out or anything, but co-vertices. Now this is all just kind of on this special little orange box. And then there are foci, too, for hyperbolas. And turns out foci on hyperbolas wind up sort of in the dish, just like on parabolas. So these are the foci. And the equation almost looks exactly the same as an ellipse, except for, do you see it? What's different about this equation and an ellipse equation? The minus sign. So if it has a minus sign, that's your indicator that's a hyperbola, not an ellipse. And then, you know, whatever your vertex number was, you're going to put that under. And whatever your co-vertex number was, you're going to put that under, just like on your ellipses. And then you're probably wondering, Mrs. Backlund, how do we find the foci? To find the foci, we're going to use the equation, right? A squared, but get this time it's plus b squared equals c squared. Remember, for ellipses, it was a squared minus b squared. So the equation for hyperbola has a minus in it, but the little a squared b squared has a plus in it, so it's just opposite. So that would be how you could find your foci. Not all hyperbolas run horizontally, I guess you'd say, with a horizontal major axis, right? Some of them could go up and down. So here's another example where the major axis runs up and down. So the difference here is in the equation. Now watch carefully. Watch what I'm about to do. Do you see this equation over here? Since this hyperbola is opening up and down, what actually happens is we have to put our y squared first. So when you see an equation that has a y squared minus the x squared, that's your indicator that y is in charge and your hyperbola opens up and down. And your vertices, wherever those are vertical, so they go under your y. Your co-vertices on your minor axis, just like that. And still, a squared plus b squared equals c squared if you wanted to find out where those foci are. If you're looking in your book, you should know that the transverse axis is just a fancy name for the major axis. I don't really know why they use different names. Just FYI. And the conjugate axis, just another name for the minor axis. This book is the only time I've ever heard it called these strange things. And then the endpoints on the conjugate axis, right? The endpoints on the conjugate axis, I've been calling them co-vertices. So, just some language stuff to watch out for in your book. So let's do an actual example now that the theory has been there. So here's an equation. I know that this is a hyperbola because the x squared and the y is squared, and it has a minus sign, not a plus sign. Had it been a plus sign, it would have been an ellipse. Same thing on our ellipses, we always need to have a 1 over here. So I'm going to kind of play with my equation to get it in standard form. Okay, so now we're in standard form, and I'm going to go to the graph. By the way, just to keep it simple, we're keeping all of our centers at 0, 0 today. You know the drill. So I'm going to try making the orange box, which just is kind of a grid line for making the actual hyperbola. So you'll see that under the x squared, we have a 9. So that means horizontally, we're going to go 1, 2, 3, 1, 2, 3. And vertically, we've got a 2 squared. So I'm going to go 1, 2, and 1, 2. And here, normally, this is when we would make our ellipse. But instead of connecting those to make an ellipse, we're going to make kind of this box thing. It's like the hyperbola box. And the reason that you make that box is because the box determines your asymptote. So if you can just draw in the diagonals of the box, that's going to be your asymptotes for your hyperbola. Okay, none of that is the graph of the hyperbola. That's just kind of your grid lines to get you going. So now we're ready. So now the question is this hyperbola going to go back and forth, or is it going to go up and down? And the answer is, since the x squared comes first, it's going to be side to side. So your vertices land right on the box, and your curves just kind of shimmy up next to those asymptotes. And there's a graph. And we could throw some foci in there, but that's our basic graph. So let's write down our vertices. Our vertices are 3, 0, and negative 3, 0. I'll let you call them co-vertices, or endpoints of the conjugate axis. That would be 0, 2, and 0, negative 2. And our asymptotes are lines, right? So it's going to be like a y equals mx plus b. And the slope of our lines, let's talk about that. The slope of our lines is going to go up 2 over 3, because that's how we got to the corner of our box. So up 2 over 3 is our slope, and our y-intercept is at 0. So I'm going to go with the slope is 2/3, and the y-intercept plus 0. So that's this first one. And then the second one just has a slope of down 2 over 3. So negative 2/3 x. So these are two equations for the lines that are the asymptotes of the graph. Let's find our foci. A squared plus b squared equals c squared. Since it's plus, you don't even have to get hung up on which one's a and which one's b. Just go for it. So if we go over here, we could say a was 3 and b was 2. Whatever, it doesn't matter. So we'll go 9 plus 4 equals c squared. C is going to be the square root of 13, which is 3 point something. So you're going to go from your center, 3 point something, and 3 point something to get out to your square root of 13. So your foci are at plus or minus the square root of 13, 0. And eccentricity, lucky for us, it's the same exact formula. But you'll remember that eccentricity is between 0 and 1 for ellipses. But for hyperbolas, well, let's see. What's it going to be? Square root of 13 over, and now the a has to be the vertex number, and you'll remember our vertices are at 3, so I guess it kind of does matter which one is a and which one is b. So whatever that turns out to be, square root of 13, I have no calculator with me. Give me a second. Okay, we're back. I got 1.2-ish for the eccentricity for my hyperbola. And so that just kind of, the eccentricity kind of just defines how curvy the hyperbola is. So there's one example. Let's look at another one. I'm going to go straight to the graph. 4, 0, -4. Covertices at 6. And so here's an example where the covertices are bigger, and that's fine. It doesn't matter at all. So that just kind of tells us where our box is. Remember, the box is not part of the graph. It just kind of helps us get our grid lines in. The diagonals of the box being our asymptotes. And there we go. So the actual hyperbola, since it said the vertices were these two, this is going to be one of those special up and down like ones. So it's supposed to actually hit those vertices and then follow those asymptotes out. So that's pretty much the graph. We can find our foci. Let's go to the equation. That sounds fun. So since it's an up and down equation, we're going to start with our y squared minus our x squared equals 1. Up and down was 4 and 4. Side to side was 6 and 6. Bam. Here's the equation. Easy. And then we need to do our asymptotes. Hey, guess what? Our asymptotes are all going through 0, 0. So you don't even have to worry about your y-intercept ever, today at least. It looks like our slope is up 4 over 6. Up 4 over 6. If you reduce it, that's fine too. So we'd have y equals up 2 over 3, same thing, and y equals -2/3. X are our two asymptotes. Let's throw it into the eccentricity and foci. So I guess I need my c, so and this part's easy if you already have the equation, huh? Because it doesn't really matter which one you use, you're just adding them together. So we do our 6 squared and our 4 squared, and that's like 52. So then you got the square root of 52, which is 7 point something. And so from the center, and the foci are always in the bowls of the hyperbola, so I'm going to go up to 7 point something, and down to 7 point something, and that's where my foci are. So I guess the foci are at 0 and plus or minus square root of 52. Foci, and the eccentricity, here we go. Eccentricity is the c value over the a value, which is the vertex number, and the vertices were at 4. So we got to put a 4 there. I have a calculator now, and that equals 1.8. Ish, 1.8-ish. And so that just kind of describes the curviness. I don't know. Do you notice anything different between these two? That one kind of looks flatter to me, at least how I drew it. So maybe the flatter it is, the higher the eccentricity. It seems reasonable. All right, one more. Let's do one more. Let's see. Let's graph it. Vertices at 3 and -3. And this is strange because they're giving me asymptotes. So my asymptotes go down 2 over 1, down 2 over 1, down 2 over 1. So by the time they get out to 3, they've gone down 2 over 1 thrice. Is anybody with me? I don't know if that made any sense to you. So down 2 over 1, down 2 over 1, down 2 over 1 to get out to the corner to make our box. That was a little complicated. Let me talk you through the other one. So the other asymptote is at positive 2x. So if we go up 2 over 1, up 2 over 1, up 2 over 1. I just needed to make it out to 3, right? So I think I've made it up to 6 and down to -6. And those would be my covertices then. I'm gonna fill that in. My covertices are at 6 and -6. And since it said that these were the true vertices, this is a side-to-side hyperbola, kind of a wide open one. Side to side hyperbolas start with an x squared. Remember the minus sign. Side to side went 3 and 3. Up and down went 6 and 6. There's your equation. And let's do some foci. So again, it doesn't really matter the order. Oh, that was weird that I put that order. Anyway, 45. So like 6 point something. And so in the bowls, we're out to 6 point something and out to negative 6 point something. Okay, eccentricity, the focus number over the vertex number. And here we go. I feel like I should be able to do this in my head or something. 2.2-ish. Does that go with my little hypothesis that the more kind of flatty it is, the bigger the eccentricity? Sort of seems true. Oh, there's another one. That looks fun. I think we'll skip that for today. And I hope you learned something. I hope the notes help. Do your best. And if you have questions, I'll be back on Monday.